Let's see the melting point and boiling point of some of the compounds. For example, ice. So its a melting point is 0 degrees Celsius, and phosphorus, it is 44 degrees Celsius. Okay, and sulfur, so that is going to have a 115 degrees Celsius. Silicon dioxide or silica, so that is going to have a 1710 degrees Celsius. And carbon, it's in diamond, so it is going to have a 3550 degrees Celsius. Okay, so one thing you can see, that is, the diamond, it is having diamond and silicon dioxide, it is going to have a very big melting point. What you can understand from that is, see, these are actually, it is not just a simple small molecules, but it is a giant structures. For instance, you can see the structure of diamond, and diamond, it is only made with carbon. So do you know how the carbon it is made? So the diamond, it is each carbon, it is bonded to 109 degrees Celsius, 109 degree. So again this carbon again bonded to 3 carbons. Again this is bonded to, here this is bonded to 1 2 3 1 2 3 4. Same way this is again bonding to 1, so this way 2 3, so this way, and again this carbon, so this is again bonding to, the remaining, like every carbon you can see this. So each carbon, it is here 1 2 3 4. So each carbon, this carbon 1 2 3 4, each carbon, it forms, it binds with the carbon. So, and moreover, at this bond between these carbons, it is actually through the this is actually nothing but covalent bond, due to the sharing of electrons. It is a covalent bond between the electrons from both carbons. Okay, see the structure of a diamond, and let's say a house. For instance, you can see that now, and it is a very beautiful structure. Now, what purpose a diamond is using? Actually, this is only one element, and moreover the bond is also strong. It's a very difficult to break this force of attraction. And diamond, it is having, it is actually one of the finest substance. It is a very hard, it is one of the hardest substance ever known in the nature. And it is it's a jewelry. And now, how about its melting point? See, the melting point is this much high, more than 3000 degrees Celsius, because you can't break this force of attraction between carbon atoms. So very difficult to break the force of attraction between the carbon atoms. So the diamond is a very its melting point is a very strong, and now it can't conduct electricity. It can't conduct electricity, right? Because why you can't conduct electricity? Because it does not contain any mobile electrons. Okay, any mobile electrons, and there won't be any free moving electrons or ions. So it is very difficult to conduct the electricity in this diamond. Okay, silica, it is similar to diamond. See, silica actually, if you happen to see its melting point, that is also close to 1710. See, the silica, each silicon atom, it is bonded to surrounding oxygen atoms in this way. Actually, it comes in this way. Silicon and again oxygen, again, so this goes to silicon, this goes to silicon, and oxygen, silicon, and oxygen, silicon, and oxygen, silicon, and here, and here. So I will draw here. Okay, so this way. So each silicon, it is bonded to oxygen atoms. So again, you can see here this bond, it is nothing but a covalent bond, which is having equal contribution from electrons from here, electrons from this silicon atom. So due to that, what you can understand is, see, this silicon atom, that is also going to have a very strong network type of structure. And so due to that, it is going to have a very strong boiling point, and very difficult to break this force of attraction between this both the silicon and oxygen. And It is almost you have to give a lot of energy. And same like a diamond, this is also one of the very hard substance. It is a it's very hard, like for sandpaper and grinding the sand, and it will be using mostly actually silica. You can see in the sand, what you call major component in the sand is nothing but silica. Okay, yeah. So similar to diamond and silica, there is again one more giant covalent structure, that is graphite. See, graphite is also, it is only made with the carbon. So if you happen to see the graphite, its structure is something like this. Each carbon, it is bonded to 3 carbons. So again, this carbon, so 1, 2, 3, 4, 5, 6. 6 carbon atom will be there in each ring, and this carbon, it is bonded to, in this way it is supposed to come. So intermittently there will be a double bond, and one thing you can understand, carbon, it is able to form 4 bonds if it is forming only single bond, right? Here you can see there is a double bond. So this electron, see, since this carbon, it is having only how many bonds? Yeah, so this, yeah, carbon actually it forms only 3 bonds. I'm sorry here. Okay, so it will be only forming 3 bonds. So total, it is only bonding with the 3 carbons, not 3 bonds, 3 carbons. So the 4th electrons, where does it will go? It is supposed to stay with the carbon ring. So this electron, it can move from here, this electron here, it can move here, it can move here, it can come here. So throughout the graphite, these free electrons and mobile electrons, it is running. It will be moving. Due to that, graphite shows conductivity. And one more thing, if you observe the graphite through the microscope, same like this, okay? So here again one more layer it will be there. It is something like a layered structure. So it is like a layered structure, and so this is one layer, this is again another layer, this is again another layer. So the electrons, it can move through the layer, not between the layer. This is not possible, this is possible. So due to that, what you need to know, the electrical conductivity will be through the layer, not through vertical. Not through the vertical manner, electrons conductivity will not be there. Okay, and one more thing, the graphite, it is not very hard. It is a slippery in nature. So it will be moving like this. One layer, it will be moving through the surface of another layer. Due to that, it shows the slippery nature, and it is one of the very good lubricant. Okay, it is a very good lubricant, and particularly it uses in high temperature applications, because the melting point of graphite, it's very high, more than 1000 degrees Celsius. So due to that, what you can understand is, it uses as one of the lubricant in many of the applications. Okay, in order to see its layered structure, what you can understand, so if you observe through microscope, you can see that the layered structure, it is very much visible, and the layer structure, it is you can see. Let's see some of the applications of graphite. These giant molecular structures. See, a diamond, for instance, a diamond is it is a very hard substance, so it uses for cutting certain cutting and grinding purposes, okay, and for drilling and cutting purposes. And now graphite, it is slippery because it is having 2 layers, so it is slippery. It is slippery. And so due to that, it is going to use as a very good lubricant. Now in pencil, see, for writing purposes, it uses along with the pencil, it mixes with the clay, and it uses along with the pencil. And now also one of the very good electrode materials, it is a conducting material. So when it is connected to brushes in generators and all, it is a electrode material. And now, how about silica? Yeah, silica probably it is a very, it got a layered structure with network type of structure, and it uses in sandpaper. And also silica, probably you may not know, in making lenses and glasses, and silica is having high melting point and boiling point. So in bricks, particularly in furnace in the sense in metallurgy applications, the furnace it is there. So in furnaces the silica will be lining on the surface, and in that applications too it is getting used.